third graders, it's Miss Fisher. Today is week 8, day 3 of our distance learning, so go ahead and grab your packet or a piece of paper and we are going to get to work. Before we get into our do now, I want to quickly go over polygons because that is a big part of our do now. So, let's take a look. So a polygon, as you can see here, is any shape with a straight line that's closed. So as long as it's got straight lines and it's closed, the lines can't be crossing each other or intersecting. And it can't have any curves. So a circle is not a polygon. But a polygon can be a funky looking shape like this one. And they all have different names based on what the amount of sides are. So like these are all quadrilaterals, but you might say, well, that's a square and that's a rectangle. Absolutely, both names are true. So these are polygons. They're flat, they're on paper. Next, I want to talk about the lines. Parallel lines never touch each other. They just run right next to each other the whole time. So even though this one's shorter, if it kept going, these guys are running right beside each other. Perpendicular lines cross each other to make corners, right angles. And then an intersecting line is a line that crisscrosses, but it doesn't make an L like a perpendicular line does. And then just really quickly to talk about the different angle types, like I said, a right angle is like a square corner. It's perfect. It's an L. It's 90 degrees. An acute angle is an angle that's smaller than a right angle. So it's teeny tiny. It's tiny and cute. And then an obtuse angle is an angle that's bigger than a right angle. So if it's bigger than like an L, obtuse, smaller than an L, it's teeny tiny acute. We've never taught you guys that, so we just wanted to quickly touch base on that before we got into our do now. Now let's take a look at the do now. Okay, it says, or the warm up, sorry. It says compare polygon M and polygon X. So I went ahead and highlighted those for us. What do we see that's the same? And what do we see that's different? Well, I noticed one thing that's the same about, actually, you tell me something. Yeah, I noticed that too. One thing I'm going to write down that is the same is they all have straight sides. They have multiple sides. Let's see how many they each have. 1, 2, 3, 4, 5, 6, 7, 8 sides for X. 1, 2, 3, 4, 5, 6, 7, 8 for M. So they both have 8 sides. Please excuse my handwriting. They both have 8 sides. Period. Do their sides look the same though? No. So what I'm looking at when I see polygon M is that all of its sides are the same. So I'm going to write, but I noticed that polygon M has all sides the same size. I didn't leave enough space for myself. Whoa. And polygon X has different sized sides. It's funny to say those two words right after each other. I'm going to write the word diff because my finger's having a hard time. Different sized sides. There are a bunch of other things that you probably noticed. If you noticed something that I didn't write, why don't you comment it in the comment section? I want to know what you noticed because there's definitely some other things that you could say are the same and are different for polygon M and polygon X. But let's move on. I have 6 equal sides and 6 equal angles. I have 3 sets of parallel lines. I have no right angles. write the letter of the polygon described above. So we need to figure out which polygon they're talking about. Right off the bat, I know they're not talking about X or M because we just figured out those have 8 sides. I want something with 6 sides. So I also know N has 4, Q has 3, S has 4, W has 3. I knew that just by looking at those because I know what those shapes are. Oh, and R has 4. So now I need to count my equal sides. Let's see. T has 1, 2. Well, actually, I wonder if T's sides are equal. The top and the bottom, they're not the same. So it can't be T. Get out of here. Same with V. V does not have all equal sides, does it? So that can't be the answer. That's a really important word. They almost tricked me. Equal sides. All right. O definitely doesn't have all equal sides, so let me cross that out. All right, U and P both have equal sides. I need to count the sides to figure out which one we're talking about. 1, 2, 3, 4, 5, 6. 6 equal sides. All of the angles appear to be equal from what I can tell. They're all obtuse. So this shape is polygon U. Woo! Now it says estimate to draw the same type of polygon as part A, but with no equal sides. So they want us to draw some sort of kooky shape that has 6 sides that aren't equal. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I think I did it. These two look kind of close to each other, honestly. I might want to stretch that one out a little further. Go down like that. But, you know, do your best. Get a little silly with it. Have a little fun. All right, let's move it along. Here's our new learning for this week. We are still talking about fractions. I know that yesterday with Miss Fifield, you looked at equivalent fractions on a number line. Today we're going to look at them with models. So they have this cool thing and they matched the fractions that were equal. Let's see what their thinking was for how they knew which fractions were equal. It says, I can imagine the 2 shaded parts in this column moved to the center column, which makes it easy for me to see 1/3 is equivalent to 1/9. So what they said was, let's pretend that instead of these 2, it's these 2 that are shaded. So now when you're looking, it's pretty easy to see. You can imagine that there are columns here, just like on the other one. I'm trying to show you the shape outlined. So now we can see, oh look, this is the same. The column is filled in. So 3 of those was the same as 1/3. 3/9 was the same as 1/3. Great. Let's take a look at the fourths. I can imagine the 2 shaded parts in this row moved to the top row. So we're going to imagine that this part is all filled in and this part is all white. Well, if you imagine that, you can see that these take up the same amount of space. So they are equivalent. We can only do this kind of equivalent stuff because these shapes are the exact same size. We're trying to think about how much space all of these fractions take up. Let's try. It says write the shaded fraction for each figure on the blank, then draw a line to match the fractions. So let's start by just identifying our fractions. Let me make sure my pen isn't still pink. All right. Here are my fractions. I see 2 equal pieces. I see 1 piece shaded. I know that that is 1/2. Great. Let's count here. 1, 2, 3, 4, 5. I see 5 equal pieces. That's my denominator. And I see 2 pieces shaded, 2/5. All right, now let's count up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are tenths. My denominator is 10. And my fraction is 1, 2, 3, 4. Okay, 4 tenths. And now let's try this one. 1, 2, 3, 4, 5, 6. Okay, 6 is my denominator. Draw that line. And I see that 3 are shaded in. So now I need to figure out the equivalent fractions. What they were just saying was they imagined that pieces were moved to look similar. So if I look at this rectangle, I can sort of see and imagine two columns like there were with the halves. Look, there's one half. Here's my other half. And if I imagine that this piece is colored in instead of this one, I can see that this and this take up the same amount of room. So 1/2 is equivalent to 3/6. Let's try my 5th and my 10th. So again, I can see some columns here, just like my 5ths. So right, I can see sort of 5 columns poking out, 1, 2, 3, 4, 5. And I can imagine that this guy moves over here. So that's white. And this guy moves over here. So that's white. So then I would have 2 of my columns shaded in, just like down here. So that means that tells me that 4/10 takes up the same amount of room and is equivalent to 2/5. Here's our second example. It says complete the fraction to make a true statement. So they have 2 models here. This one is showing me 3/6. I have 3 equal pieces shaded out of 6. This one is showing me 6/12. They cut some extra columns in. Now I have 12 pieces and 6 of them are shaded. So to figure this one out, we counted, right? 1, 2, 3, 4, 5, 6. I can sort of see how they drew these lines, and that could help me too. All right, now let's try ourselves. So we're just going to look at the picture this time. They already did the hard work for us. So this is my 1/2, right? Right there. Now I need to figure out what this is. For somethings, they already filled in the numerator for me. So here's 4, 5, 6, 7, 8. So 1/2 is equivalent to 4/8. Now let's take a look at this one. 3 equal pieces shaded out of 5. Great. So here are my tenths. I can see the denominator. I just need to count how many are shaded. 1, 2, 3, 4, 5, 6. And I can even look and see these take up the same amount of room, right? On both sides. So 6/10 equals 3/5. Great. Okay, here are our next 2 learning examples. So why does it take 2 copies of 1/4 to show the same amount as 1 copy of 1/6? Explain your answer in words. So this language I thought was a little funky. So I just want to talk about that for a second. When they say copies, they mean like pieces. Why does it take 2 pieces of 1/4 to equal the same amount of 1/2? How come I need 2 1/4 pieces or 2/4 to make the same space as 1/2? We're going to keep saying copies because that's what they're saying. But I don't know that that's how Miss Fifield or Miss Cotter would say it, but we're just going to keep it moving. So here's their example, their thinking, and then we'll look at their written answer. I can draw 2 models, so they drew 2 fraction strips. where each whole is the same size. It's important when we're comparing that our fraction strips are the same size. Then I can partition, remember that means to cut, and shade to show that 2/4 equals 1/2. And that's exactly what they did. They drew two equal size fraction strips. They cut one into a half and colored it. They cut another one into 2/4 and colored it. And look at that. Those are the same size. They are taking up the same amount of room. Great. So their answer uses some really awesome math vocabulary. Let's take a look. There is double the number of equal parts in fourths than halves. So you need double the number of copies to show equivalent fractions. They used some really, really nice mathematician vocabulary here. They wrote out their fractions as words. And they used this word double. Double means 2 times. So like if you've ever seen anyone doing double Dutch, jump rope, they have 2 ropes. That's why it's double Dutch. So what they're saying is you need 2 times the amount of fourths as halves to make equivalent fractions. You need to double the number of copies to show the equivalent fractions. So now let's take a look at our next example before we try on our own. This question's a little bit different. This question, they didn't tell us how many copies we need. How many eighths does it take to make the same amount as 1/4? Explain your answer in words and pictures. When they say words and pictures, when they say pictures, they mean to draw a fraction bar. So let's see what they thought. They said, my models show that for every 1/4, there are 2 eighths, right? Here's 1/4. Here are 2 eighths. Okay. Eighths are smaller units than fourths. Absolutely. So it takes more eighths to equal 1/4. So I need more of these to equal this because they're smaller units. I'm sharing with more people. Let's take a look at their sentence. It takes 2 eighths to make the same amount as 1/4 because there is double, again, that awesome word, 2 times, the number of equal parts in eighths. So it takes double the number of copies. So again, they're just saying this is double this. It takes up, you need 2 of the pieces, right? To make the same size. That word double is just a quick way to say 2 times. Let's try it ourselves. Let me get my pen back. So I have some fraction strips.
So why does it take 3 copies of 1/6 to show the same amount as 1 copy of 1/2? They said we could explain using words and pictures. It is a little difficult for me to draw fraction strips on the computer, as you've probably noticed, so I found this great tool. I'm going to use these fraction strips to help me. I want you on your paper to draw best you can. So I'm going to start by pulling out my 1/2 fraction strip and putting it out. You can see I have 1/1/2 piece. If I had 2, I would have 1 whole, but I have 1/2. And they wanted to know, why does it take 3 copies of 1/6? So after I draw my fraction bar with 1/2, I'm going to draw a fraction bar with 1/6. 4, 5, 6. Here are my sixths. It's extremely important that your pieces are really lined up. So I made sure my ends matched. And then they said it takes 3 copies. So I'm going to throw out 3 copies, and yep, they're right. It takes 3 copies to take up the same space as 1/2. So I've shown them that with my picture.
Now let's show with words. So I've talked to you guys about this before, but when I am trying to think of a good sentence and there was already an example sentence, I'm going to go ahead and try to use that as like a sentence stem or a sentence frame like Miss Cotter or Miss Fifield or I sometimes give you in class. So I found their sentence stem and I filled in my own words. So let's take a look. There are triple. So I did have to change the word because we mean 3 equal pieces, not 2. Triple means 3 times. I put that in my sentence. There are triple or 3 times the number of equivalent pieces in sixths than halves. So you need triple the number of copies to show equivalent fractions. This is the sentence stem they already used. I just changed some key math words to apply it to my answer. That's okay. So now I've told them my thinking with words and with a picture. If you don't have both of these things on your page, pause the video here, get it written down. We're going to move on to the next section. How many ninths does it take to make the same amount as 1/3?
Strips again. For this question, how many ninths does it take to make 1/3? So we're going to use these fraction strips to help us figure out those equivalent fractions, and you are going to draw it on your paper. So first I need to find the row with ninths. 1, 2, 3, 4, 5, 6, 7, 8. Nope. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my ninths. And I'm trying to make them equal to thirds. So I'm going to pull out 1/9. Actually, let me pull out my thirds first. So here are my thirds. I have 1/3. I can check to make sure I pulled out the right one. If I had 3, it would be full. Great. So here's my 1/3, and I want to know how many ninths are equal to 1/3. So let me line them up. Now on your paper, you're going to draw blank fraction strips first and then fill them in. So here's 1/9, 2/9, 3/9. So I can see that it takes 3/9 to make the same as 1/3.
So now I need another sentence because again, I've got this wonderful picture, but they asked for words and a picture. So I've got my picture here with my fraction strips. Now I need to explain to them what my picture means. Again, they had a pretty awesome sentence in the example, so all I'm doing is going to fill in with the appropriate word. That's okay. It takes 3/9 to make the same amount as 1/3 because there are triple or 3 times the number of equal parts in ninths, so it takes triple the number of copies. I told them exactly what this picture shows. For every third, there are 3/9. Okay, so this is just like we did before in our example. It says write the shaded fraction for each figure on the blank, then draw a line to match the equivalent fractions. So we're going to have to use our imagination for this one a little bit, but first let's just label the fractions. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9. I wonder if any of you were tricky enough to count by threes there. So I know 9 is my denominator and I see 3 shaded. So I've got 3/9. I see 3 equal pieces here. And I see that 2 of them are shaded in. So that fraction is 2/3. I see 3 equal pieces here. And I see 1 shaded in. And that's 1/3. All right. And now let's count here. 1, 2, 3, 4, 5, 6. 6 equal pieces. 1, 2, 3, 4 of them are colored in. So I've got 4/6. So now it's that time where I need to kind of use my imagination. I'm going to start with the 4/6 because it seems a little easier because all I really need to do for 4/6 is imagine that this piece was here. Okay? I wonder if I could do... Ooh, and then this section's white. Okay, here we go. So imagine that it looks like this instead. And then you might notice that we have 3 columns going up and down, and 2 of them are filled in, just like this picture. So I know that 4/6 takes up the same amount of room as 2/3. All right, now let's try my 3/9. So I'm going to move these boxes all next to each other. So first, let me take my black highlighter and color this in best I can. Okay, now let me take my white highlighter and help me imagine a little better, help us imagine a little better that these are all white now because we moved them up. Okay, great. So now I can actually see that actually I have 3 rows, just like in my thirds, and the top one's the only one filled in, so I know that 3/9 is equivalent to 1/3. Good job, guys. All right, write the missing parts of the fraction. So I see 1/3, and I see these are sixths. They already counted all the equal pieces for me, and only 2 of them are filled in, so that's 2/6. All right, 1/4, that's this one. Let's see what's up here. 2 what? 2, 4, 6, 8. 2/8. 2/8 is equivalent to 1/4. All right, whoa. So we've got 4/8 up here because there's 1, 2, 3, 4 pieces colored in. This one, they cut those pieces up, so now there's 8 equal pieces, see? So now we need to count the white ones. 1, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16ths. So 4/8 is equal to 8/16. Again, you can pause at any time if you need to copy down some answers. All right, why does it take 2 copies of 1/8 to show the same amount as 1 copy of 1/4?
First, let me pull out my 1/4 piece, and you should be drawing 2 equal fraction strips. Cut 1 into fourths and shade 1/4. Now let's get our eighths. 1, 2, 3, 4, 5, 6, 7, 8. Remember to line them up because we can't compare if it's like that, can we? We can't tell. So we got to make sure they're lined up. Here's my eighth. Here's my fourth. I have double the amount of eighths. I have 2 1/8 pieces that take up the same amount of space as 1 1/4 piece. So that's what we need to show them with our picture.
All right, so now we need to write another sentence. Again, this question is just like almost every other question we've worked on, so I have a great sentence stem to work off of.
First.
Oops, sorry. So, I just went back to doubles because, let me get to my picture. There we go. For every 1, there's 2, and we know that double means 2 times. So there are double the number of equal parts in eighths than halves. So you need double the number of copies to show the equivalent fraction. I meant fourths. I need to change that, huh? Whoops. And fourths. Whoops. I'm sure somebody out there shouted it out, and that's why I caught it. Because we're not talking about halves, Miss Fisher. Silly, silly, silly. All right. Let's move on to our next one. How many sixths does it take to make the same amount of thirds? Let's see.
The sixths are the same as a third. Let me pull out my 1/3. Here it is. And here are my sixths. So let me pull that out and see how many sixths I need. They say how many copies do you need? So let's see. 1, Not equivalent yet. It's equivalent, so I needed 2/6 to make 1/3. I needed 2 copies of 6 to make thirds.
I just realized it's sometimes hard to see, but now you can see those are 6. All right, so now let's get my sentence here. All right, it takes 2/6 to make the same amount of thirds because there are double the number of equal parts in sixths. So it takes double the number of copies. Again, I went back to double because it's 2 times. We did it! Hooray! Give yourself a pat on the back. Today was hard work. I'm sure you did a lot of drawing for your fraction strips. Don't forget to get on ST Math. Don't forget to get on Zearn. And practice your multiplication facts, which I will link here. Keep being awesome. I'm proud of you guys for working so hard, and we will see you tomorrow back here on YouTube. Bye, guys.